Welcome back. Let's continue with chapter 5. So, what we're going to be doing now is go deeper into what ionic and a molecular compound is. So, let's do that by practicing some of the problems. So, let's begin with this problem. Classify each compound as ionic or molecular. Quick review. Ionic is going to be a metal combined with a non-metal. A molecular compound is going to be a non-metal combined with a non-metal. And as we look at this division on the periodic table, our metals are going to be on this side, including the ones down there, except for hydrogen. We know hydrogen is a gas, not a metal. So everything but hydrogen. And then my non-metals are going to be on this side of the periodic table. And you already know about the metalloids, which are going to be the ones touching the steps on both sides, except aluminum. So that's the general division on how we know what is what and how we can classify the compound that they form as either ionic or molecular. So keep that in mind. So a problem like this, classify once more as ionic or molecular. If it happens to be ionic, then let me know if the metal have one type of ion, and this is something we're going to go deeper very soon, or more than one type of ion. How do we know if the metal have more than one type of ion or not? Well, it has to be a transition metal. Where are my transition metals? My transition metals are going to be this block here, including the ones at the bottom. So all these can have more than one type of ion. What do I mean with that? That means that, for example, iron in some compounds can be 2 plus. It can also be 3 plus in another type of compound. Meanwhile, sodium, which is not a transition metal, will always be plus 1. There's only one type. The transition metals can be 2 types. However, science is never 100%. There's always exceptions to the rule. So here are my exceptions. Zinc, cadmium, and silver, even though they are transition metals, only have one type of ion. We have not been able to find any other type of ion in nature so far. So this is something you should memorize or have a note somewhere. Zinc will always be 2 plus, and that always is between quotation because nothing is 100% in science. Cadmium is 2 plus, and silver is plus 1. So this is extremely important to remember whenever we start putting compounds together, because very soon, once we leave chapter 5 behind, we're going to start using those compounds to put chemical reactions together. And everything after that is going to depend on you being able to write the compound formulas the right way based on the charges. So remember, everything on yellow, those are my transition metals. They can have more than one type of ion, like iron 2 versus iron 3, except for zinc, cadmium, and silver. Zinc and cadmium 2 plus, silver plus 1. So put that on your memory bank or your index card, whatever method works better for you. So back to the question. Ionic or molecular? Let's begin with that. So this one has potassium, which is a metal, and chlorine, which is a non-metal. Therefore, this one is ionic. This one has carbon, which is a non-metal, combined with bromine, which is a non-metal. Therefore, molecular. This one has nitrogen, which is a non-metal, combined with oxygen, which is a non-metal. Therefore, molecular. This one has tin, which is a metal, combined with sulfate. So what is that? That's what we call a polyatomic ion. We will be talking about that very soon, but as you notice, sulfur and oxygens are non-metals. So in general, this is combined with non-metals. Therefore, ionic. So this answers the first part of the question. If it is ionic, so this one and this one, so only for the ionics, determine whether the metal forms only one type of ion or more than one type of ion. So the metal here is potassium, not a transition metal, so only one type of ion. The metal here is tin, which is not a transition metal. However, tin is one of the exceptions. Tin will have more than 2 ions. So how are you supposed to know that if it's not a transition metal? Well, when you read the textbook, it tells you some of the exceptions. So when you do this, make sure you're referring to the notes on the textbook. Lead is the same story. So basically this square. So let me tell you that. So the same way that we have elements that are transition metals, but that do not follow the rule of the transition metal, we have this group over here that are elements that are not transition metals, but behave like transition metals in the sense that having more than one ion. For example, lead, we have found compounds of lead that are 2 plus and 4 plus. So like I said, nothing is 100% on science. So remember, make a note of this. These are the transition metals that only have one ion. These are the non-transition metals that have more than one ion. Everything else, for the most part, follows the rules that I told you. So let's practice some more. So now that you know how to identify an ionic versus molecular, now it's talking about something else, the basic unit. So when you have a compound and you have it on your hand, which is a big quantity, and you break it down to the smallest you can go before you destroy the compound, similar to the elements and the atoms. So will the smallest unit be a single atom, a molecule, or a formula unit? So a formula unit is a new concept that we haven't touched yet. So a formula unit refers to ionic compounds. So if you have an ionic compound, you do not have a molecule. Even though I told you that when you have 2 atoms bonded together, you have a molecule, it's 2 atoms or more bonded together. An ionic compound is not like that. An ionic compound is a cation attracted by an ion. They are not bonded together. It's just like a magnet. When you have a magnet, they are just attracted to each other, but there's nothing like a screw or anything holding them together. So when we talk about ionic ions, we cannot talk in terms of molecules. We have to talk in terms of formula unit. So in other words, if you have an ionic ion, you have a formula unit, as simple as that. So now with that out of the way, let's go ahead and find this. So first thing, let's find which one is ionic, which one is molecular. The problem is not asking you to do that, but to answer the problem, you have to know that. So this is so the first one, barium, is a metal. Bromine is a non-metal, so this one is ionic. The second one is just an atom. So we already answered that. So this would be a single atom. When you break it down to the smallest you can go before disappearing. This one is iodine. Remember the iPhone? iPhone. Those are the ones that can make diatomic compounds, including hydrogen. So it's two of the same. It's a non-metal with a non-metal, so they're going to be bonded. So this one is going to be a molecule. That's what we said, that it's a molecular compound, because it's a molecule. And this one is the same story. You have a non-metal with a non-metal, so therefore it's a molecular compound. And we say it's a molecular compound because the smallest unit is a molecule. So the main thing you have to learn from this learning check is you have a molecular compound, the basic unit is a molecule. If you have an ionic compound, the basic unit is a basic unit. That sounds simple, right? The basic unit is a basic unit for the ionic compound. So you're ready for your daily work. So let's attack both concepts at the same time. So remember, determine first, is the compound ionic or molecular? By looking at the periodic table, and then from there, everything else falls into place. So with that, I would say that you can distinguish now between a molecular element versus an atomic element. An atomic element would be something composed just of something like that: sodium, 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 sodium. A molecular would be something like this, for example, composed of at least two or more elements. And then we classify the compounds as ionic or molecular. And we said that if you have a compound, two or more elements that are different, if this is a metal and this is a non-metal, then you have ionic. If this is a non-metal and a non-metal, then you have molecular. And you have to know which is which by looking at the periodic table. So, new concepts. How do we write the formula for ionic compounds? So you were able to recognize them. You know how to write by putting the most metallic first and so on. But how do we write the formulas for any ionic compound, which is a metal combined with a non-metal? For that, you're going to have to learn something first. And I would like for you to learn this and not just memorize it, because it will save you so much and it will prepare your brain for other stuff that is coming. So I'm going to tell you what you need to memorize first, and then I'm going to tell you why it's like that. So anything on this column, if it was part of a compound, it would be 1 plus. Anything on this column, if it was part of a compound, so when they're by themselves, they're just 0. But if this was part of a compound, it would be 2 plus. for what we're doing here, we're not going to think about this. So the transition meters are non-players on this. Anything on this column will be 3 plus. There's something special about this column, so we are not going to talk about that column. And then anything over here will be 3 minus. Anything here will be 2 minus, and anything here will be 1 minus. So it's like a pyramid. Starting on number 1, 1 plus, 2 plus, 3 plus. Do not do anything with the carbon. Then 3 minus, 2 minus, and 1 minus. And why is that? Well, let me show you something. I mentioned before that we had different types of families. We had the halogens, we have the alkali metals, the alkaline earth metals, and then we have the one that I really want to talk about, the noble gases. So the noble gases, they are on group 18. And what's relevant about this is this last number, the number 8. Let's take, for example, argon. If you notice, argon is number 18. That's the atomic number. So argon have 18 protons, as you already know. Anything on the periodic table is neutral. When they're part of a compound, that's when you see those charges. But argon by itself is neutral, so if it have 18 protons, it has to have 18 electrons. So let me introduce you to something new. So we know, based on the Rutherford model that you already learned, the atomic model where we put the nucleus on the center, you know that argon is going to have 18 protons on the nucleus. It's going to have several neutrons in there, but I don't care about the neutrons at this time. I only want to talk about the protons. So you got 18 protons there. And if you notice, argon is on period 3. Why is that significant? Period 3 means that the electrons are going to be distributed in 3 different energy levels. Remember, electrons are negatives, so you don't want to put electrons close to electrons. So they're going to spread apart. They want to be close to the nucleus because the nucleus is positive, but not all of them can be close to the nucleus. So they're going to have to compromise and spread apart. You should memorize this. On level number 1, which is the smallest level compared to the other one, right? On level number 1, the maximum you can put without having to fight too much is going to be 2 electrons. Level number 2, which is a little bit bigger, you can also put more than 2, but 8 electrons in there without having to repel each other too much. And level number 3, the maximum you can put also, there's more to this one, but we're not going to go there yet, is 8 also. So that's where you get the 18. 2 plus 8 is 10, plus 8 is 18. So 18 protons, 18 electrons. And that's perfect. That's balance. That's what nature wants. Nature wants, if you only have one energy level on one period, nature wants to have 2 electrons there, full. If you have 2 energy levels, nature wants the last one to be full, 8. And if you have 3 energy levels, nature wants the last one to be full, 8. And that's what you see on the noble gases. they all have the last energy level always full. So every other element in the periodic table wants to be stable, so they're gonna do whatever they need to do to be stable like the noble gases. They want to have 8 electrons on the last shell. So the only way they're gonna do that is by combining themselves with other elements. So that's how we go from elements to compounds. So when I tell you that anything on group 1 is gonna be 1 plus, this is what it means. Let's take, for example, sodium. So sodium is atomic number 11. So let's do that. So 11 protons, 11 electrons. So let's do sodium then. So instead of 18, we're going to have 11. So we need to put 11 electrons in there. We have 2 on the first one, 8 on the second one. That's 10. So we don't need 8 on the last one. We only need 1 more electrons. That will give me 2 plus 8 plus 1. That will give me the 11 electrons I need. So here's the problem. I told you that all the elements want to be like the noble gases, right? So if I have 1 electron here, sodium is going to have to get 7 more electrons to be happy like a noble gas. So that's what we want. However, those electrons are going to have to come from other elements, and the elements want to be like noble gases, so they do not want to give those electrons up to sodium. So there's going to be a lot of fighting for those electrons. There's going to be a lot of energy. Nature does not want to spend energy, so that's not a good thing. Gaining 7 electrons requires a lot of energy. Nature is against that. So nature instead says, you know what, let's compromise. Getting 7 electrons, way too much energy. We're not going to do that. Why not just lose this one? If you lose that one, how many do I have on my last energy level now? I have 8. So that's perfect. By losing one, it was given to another element. Now I am like a noble gas. So gaining 7 or losing 1? What's the best thing? Losing 1. And remember, I told you that when you look at the periodic table, this number here is telling you how many electrons I have on the last shell. So we know why this one is going to be 1 plus, right? Because, for example, sodium began with 11 protons. And it also began with 11 electrons, right? But we gave 1 off, so now we have 10 electrons. So when you put those two together, what do we have? We have 1 plus. That's why this is 1 plus. So let's do the other one so you can see where these numbers are coming from. So group number 2, 2 valence electrons, 2 choices. It can gain 6 more to be like 8, or it can lose the last 2 so that the level that remains have 8. What's easier, to gain 6 or to lose 2? The easier thing would be not to gain 6, but to lose 2. Therefore, in the case of magnesium, it began with 12 protons, but it lost 2 electrons. So now I have 10 electrons. So overall, it's going to be 2 plus. So that's why this group is 1 plus. That's why this group is 2 plus. The transition metals have a whole different type of chemistry, a lot more complicated, so we're not going to do that simplification there. But when we look at the group 3, two choices. It can gain 5 to have 8, or it can lose 3. Easier, always the smallest number, to lose 3. So for example, on the case of aluminum, of aluminum, which is 13, with 3 valence electrons, I can gain 5 or lose 3. The smaller number is losing 3. So in that case, aluminum began with 13 protons. It has 13 electrons, but we're losing 3. So instead of 13, it's going to be 10. So overall charge is going to be 3 plus. That's what this will be, 3 plus. In the case of carbon, it's going to be 4 and 4, so that's why we don't even go there. So we don't do that one. However, in the case of nitrogen, it has 5 valence electrons, so it can gain 3, or it can lose 5. The easiest thing is always the smaller number, so it's not going to lose 5, it's going to gain 3. So nitrogen with 7 protons and 7 electrons just gain 3. So now it's going to be not 7 electrons, but 10 electrons, which gives us an overall of 3 minus. And that's why this one is 3 minus, this one is 2 minus, and this one is 1 minus. So now that we know that, now that we understand why those numbers are the way they are, so it will serve you well to understand why group 1 is plus 1, why group 2 is 2 plus, and so on. So let's now see how we're going to write formulas. So let's do a problem with that. In addition to that, so based on the periodic table, you know that potassium is going to be plus 1. You know that phosphorus is going to be 3 minus. You know that bromine is going to be 1 minus because of the number that we just did, right? So that's why you have to understand that. But in addition to that, nature has some unique groups of elements that they are always together and they have a given charge. And we're going to call those the polyatomic ions. So the polyatomic ions is a series of groups that are always together and they have a given charge. So we're not talking about that element now, we're talking about a group or more than one poly, more than one atom together that are ions. What is an ion? An ion is a particle with a charge. So those you should have handy at all times. Even better if you memorize it. So whenever we talk about polyatomic ions, we're going to be looking at the charge and see how that works. So let's do some problem with that so you can relate to it better. Write a formula for the ionic compound that formed from each pair of substance. So the first one is sodium combining with sulfur. Sodium is on group 1, so sodium is going to be plus 1. Sulfur is on group 16, gaining 2 or losing 6. Easier to gain 2. So those are the possible ions for those two elements. So how do we know the compound? Really easy. Sodium is like a package of plus 1, while sulfur is like a package of 2 negative. When they combine, the rule is the overall charge, the combined charge, have to give you 0. So if I combine plus 1 with 2 minus, I do not get 0, I get minus 1. So what do I need more? I need more sodiums. I need another package of plus 1. So that's going to be 2 plus combining with 2 minus, that's 0. So that's what you need. You need 1, 2, you need 2 of these and 1 of those. The moment they join together, the charges cancel each other, so you do not show the charges anymore. And we do not show the one either. So that will be the formula. Let's do another one. Strontium and acetate. Strontium is going to be there, and acetate, I can spend the rest of my life looking for acetate on the periodic table because it's not going to be there. That's what you have to be familiar with this list. If it's not on the periodic table, it's because it's one of these here. So let's see if we can find acetate. First one, C2H3O2 minus. So now that we know that, so we're going to have strontium and acetate, C2H3O2 minus. And strontium is here, so that means it's going to be 2 plus. So how do they combine? Strontium is a package of 2 plus, while acetate is a package of minus 1. That's the only thing that matters, the charge. So this plus this doesn't give me 0. So what do I need more? I need more of this. So let's check it out now. So this plus these two give me 0. So that's what I need. I need one of those and 2 of these. But if you notice, if I do that, that looks like a 22. That's not what I want, and the charges are going to be gone, right? To make sure that I don't show you a 22, I put a parenthesis there. So that way, that means I have one of those and 2 of these, which is what I was telling you, 1 and 2. So once more, we do not show the 1. Let's do another one. So important to have that polyatomic table close by. Aluminum and cyanide. Aluminum is going to be here. So aluminum is going to be 3 plus. And cyanide, if I look at the periodic table once more, I'm going to start collecting my Social Security because it's not going to be there. Cyanide is going to be a polyatomic ion, and it's going to be right at the end. Right at the end. Cn negative. So now that I know what cyanide is, let's go ahead and do that. And I'm going to have cyanide. Once more, I'm focusing on the charges. So back to my analogy, aluminum is like a package of 3. Cyanide is like a package of 1. So I'm going to need altogether 3 of these to give me 0. 3 plus 3 negatives equals 0. So I'm going to need 3 of those and 1 of these. Once I do that, the charges do not show anymore. However, I do not want to tell you that I have 1 carbon and 3 nitrogens, right? That's not what I'm trying to say. I'm trying to say that you need 3 of those. So the parentheses are important whenever you see some confusion there. If I don't do the parentheses, I don't have 3 cyanides. I have 1 carbon and 3 nitrogen. That's not what I want. I want 3 CN groups. 1 group, 2 groups, and 3 groups. And the 1 doesn't show, right? So that would be, this would be my formula. And as always, the first one you write down is the one that is more metallic, more to the left. Let's do magnesium and chlorine. So magnesium and chlorine. Magnesium is here. So this is my 2 plus. So magnesium is going to be 2 plus. And chlorine is there. This is my 1 minus. So chlorine is there. Magnesium is going to be a package of 2. Chlorine is a package of 1. That doesn't give me 0. To give me 0, I'm going to have to add 1 more there. So 2 plus 2 negative equals 0, which means I need 2 of these and 1 of those. Once I do the compound, the charges do not show anymore, and the 1 doesn't have to show. And make sure that you put them close together so I know that you're talking about a compound. What about silver and oxygen? Silver is going to be right here. So be careful. Silver is a transition metal. So what charge would that be? This is 1 plus, this is 2 plus. I told you to leave this alone, right? So what are we doing in there? Well, what we're doing in there is, I told you something a few minutes ago. Silver, cadmium, and zinc, for the charges, they do not behave like transition metals. And I told you also that silver is always plus 1. So you should know that. You should know that silver is always plus 1. Oxygen is 2 minus. So silver would be like a package of 1, while oxygen is like a package of 2. So I'm going to need another one of these to give me 0. So I'm going to have 2 of these and 1 of those. Once I do my compound, the charges do not show anymore, and we do not show the 1. And that will be the compound between silver and oxygen. 2 more to go. And I know I'm taking a long time to do this part, and I'm doing that because this is so important for what's coming for the rest of the semester. You have to master this, doesn't matter what. So iron and chlorine. Iron and chlorine. Where is iron? Iron is here. Ooh, be careful, be careful, be careful. We're dealing with transition metals. Chlorine is here. I know chlorine is -1. Iron is a transition metal that I know is going to have more than 1 charge. I can tell you about silver, cadmium, and zinc, but not about iron. So I cannot answer this question, not with the information I have. I know from memory that iron can be, but you don't know that yet. I know it because I've done this a lot of time. I know that iron can be iron 2 or iron 3. The problem doesn't tell me which one. So the best answer would be, it could be that, or it could be this, but that's because I know this. You don't know that yet. I not expect you to know that. So we cannot answer that question there. We do not have enough information. And that's the most intelligent answer that you can give anyone when you do not have enough information. Do not make it up. Do not try to look good. You're going to look dumb if you make a decision and assume something when you don't have enough information. So we cannot do that one. As simple as that. I cannot give you that answer. You didn't give me enough information. And that's the answer I would expect on a test from a smart person. And what about the last one? Ammonium and hydroxide. I am not even gonna look at the periodic table for this. Those sounds weird. So I'm gonna go to the polyatomic ions. Hydroxide, I'm looking for hydroxide. Here it is. So hydroxide is gonna be OH negative, and ammonium is gonna be right here, NH4 plus. Always have your polyatomic table close by. So the last one is gonna be ammonium, NH4 plus, and hydroxide, OH negative. Some people write HO negative, really doesn't matter. You're just basically saying that this is half a negative charge. So it really doesn't matter which way you put it. So my main concern is the charges. So what I'm saying is I'm going to have a package of 1 combined with a package of -1. That gives me 0. So all I need is 1 of this and 1 of this. I want to make sure that the charges do not show after I put my compound together. And I want to make sure that you understand that I'm not telling you 41 hydrogens. I'm telling you one NH4 plus and one of that, but we do not put the ones, right? So I do not put the one, so I do not need the parentheses either. So the way to do this would be NH4 OH, and that would be ammonium hydroxide. So quick review. Anything here will always be +1 when it's part of a compound. 2 plus, 3 plus, leave it alone, 3 minus, 2 minus, 1 minus. And now you know where those are coming from. That would be a good question on the test, right? Explain why this is 3 plus or something like that. And you know that you need to use the polyatomic ions. You do not have to memorize it. Hopefully, by using it a lot, you will memorize it without even trying. Meanwhile, feel free to use the table. During the test, I will make sure that I put the table on the first page. But you can work so much more faster if you memorize it. So go ahead and do that. And after you're done with that, we're going to say that you now know how to write formulas for ionic compounds, taking into consideration the proper charges, the parentheses, and all those rules that we talk about. And with that, we're going to come to an end for this section. So we just finished part B. When you come back to the next section, we will be talking more about compounds. And we're probably going to be moving into, not ionic, because we're finishing those, but into molecular compounds. Until the next one, we'll see you later. Take care.